You're welcome to this lecture by Science Board on equations of uniformly accelerated motion, to be presented by Ugwain Joseph C. of the Department of Physics and Astronomy, University of Nigeria, Nsukka. Now, equations of uniformly accelerated motion. In the course of this lecture, we shall be dealing with deriving the three equations of uniformly accelerated motion. We shall equally be solving problems to demonstrate how these equations are used. We shall be given exercises relating to these equations, and finally we shall be given answers to these problems. Now, introduction. What do we really mean by equations of uniformly accelerated motion? Of course, these are kinematic equations which can be used to give a complete description of the motion of a particle in a straight line while the acceleration is uniform. And by uniform, I mean constant acceleration there. Now, the first equation of motion. Assuming that we are now conversant, or you are now conversant with the concept of displacement, velocity, and acceleration, we shall use these three concepts to derive these all-important equations. And by that I mean the equations of uniformly accelerated motion. Now, suppose a body which is already moving with an initial velocity u in meters per second begins to accelerate at the rate of a in meters per second squared. The velocity will now increase by the numerical value of a in meters per second for each second that it moves. What do we mean? We mean here that acceleration is given by change in velocity per time. And by that we mean the final velocity minus initial velocity divided by time. And by formula, we have that acceleration is equal to v minus u divided by t. And if we multiply all through that equation, that is the mathematical equation that says that a is equal to v minus u over t by, if we multiply it all through by t, we'll have that at is equal to v minus u. And by making v the subject of formula in that equation, we simply have that v is equal to u plus at. And that means that the increase in velocity in a time t in seconds will therefore be equal to at. Hence, the final velocity v at the end of the time t is given by v is equal to initial velocity u plus the increase in velocity at, and this gives us that v is equal to u plus at. And it's labeled equation 1, and equation 1 there is called the very first equation of motion. Now the second equation. If a body is moving with uniform acceleration, its average velocity is equal to half the sum of initial velocity u and the final velocity v. That is, average velocity is given by vu plus v all divided by 2. And having this formula in mind, we have that v is equal to u plus at. Now, substituting in our equation for average velocity, that is for v, we simply have that average velocity is given by u plus u plus at. The final u plus at simply represents v in that equation. And we have, that is, average velocity is given by u plus at all divided by 2. Now, doing the mathematics there, we have that average velocity will be given by 2u plus at divided by 2. And this can be simplified in this form, that 2u, that is 2u divided by 2 plus half at. If we further simplify, we have that average velocity will be given by u plus half at. And that is our equation for average velocity. Now, we equally have that average velocity is defined as total distance traveled divided by total time. But we have had an expression for average velocity which says that average velocity is given by u plus half at, and we simply equate it to our s over t. That is, average velocity is given by total distance divided by total time. Now, if we want to make the distance, that s, the subject of formula, we simply multiply that last equation there, the whole of the equation, by t. And if we do that, we just have that s is given by u plus half at into t. Now, if we remove the brackets, we simply have that s is equals to ut plus half at squared. And this gives us our second equation of motion. Now we can go forward to our third equation. Now the third equation of motion.